Hello everyone, my name is Stephanie. I am an assistant professor at FRA. Today I will be presenting to you what is AI, the history of AI, the branches of AI and its learning types, and also we will have a brief focus on neural networks at the end.
Have you ever wondered how your phone recognizes your face? How Netflix recommends what you love to watch next? Or how a car can drive itself? These are just a few of the incredible things powered by artificial intelligence, or AI. But what exactly is AI? And how does it work? Let's find out. We know, since the early years and up till now, computers have excelled at tasks involving calculations and rules. For instance, they are unmatched in solving mathematical equations or processing vast amounts of data. But what about tasks that come naturally to humans, like learning a new language, identifying objects in our surroundings, or even driving a car? This is where AI comes in. AI enables computers to go beyond pre-programmed rules and start learning, adapting, and solving complex problems, just like humans do. But why is AI different from conventional programming? Imagine trying to use conventional programming to recognize faces. We'd have to write rules for every possible hairstyle, every possible skin tone, every possible facial expression, etc. And let's take also the example of self-driving cars. Imagine hard coding every possible road situation that comes from pedestrians to cyclists, from green lights to red lights, and so on. In such cases, it's impossible to write rules for every situation. And this is where AI comes in. So instead of writing very specific instructions with conventional programming that is not suitable for such cases, AI learns from data and discovers patterns and make decisions just like humans learn from experience. But how did we reach here? Let us go a little bit to the past. The year 1950 marked the birth of AI. It was when Alan Turing asked the groundbreaking question, can machines think like humans? While proposing the famous Turing test, a benchmark for measuring machine intelligence. Then, in the 1956, the term artificial intelligence was officially coined in the first AI workshop. This event brought together brilliant minds to explore the possibility of creating intelligent machines, laying foundation for AI research. In the 1970s and the 1980s, unfortunately, AI had two winters. AI didn't meet expectations in the first winter, and simple problems were not even possible to solve. While in the second AI winter, the systems based on reasoning failed because software was hard to maintain and couldn't handle novel information. AI stayed out of the spotlight until the year 1997, when IBM's Deep Blue defeated the world chess champion Garry Kasparov. This marked a pivotal moment, showing that AI could outperform humans in highly strategic tasks. Moving to the years 1990s and the early 2000s, there was the technological and internet boom, where microprocessors became more and more powerful and affordable at the same time. So computing became accessible to more researchers and industries, alongside the arrival of the internet to the public and social media. All of this gave AI a new life. Then, in the year 2006, AI experienced a groundbreaking resurgence with the rise of deep learning. While neural networks have been studied for decades, Geoffrey Hinton's original work introduced effective methods for training deep neural networks. This marked the beginning of AI systems capable of learning and adapting in ways that resembled the complexity of the human brain. Then we go to the year 2017. Google Brain at that point revolutionized AI with the introduction of transformers, a new architecture that made it possible to process vast amounts of data more effectively. And finally, we go to the year 2023, where we entered the generative AI boom. Tools like ChatGPT and DALL-E 3 now are shaping our industries, from education and entertainment to healthcare. In short, AI has come a long way from just being a simple question in the 1950s to groundbreaking technologies that are part of our daily lives today. Now, let's break down the relationship between AI, machine learning, deep learning, and generative AI. You've probably heard these terms used interchangeably. but they're not the same thing. Artificial intelligence is the umbrella. It's the entire field dedicated to making machines smart, capable of performing tasks like understanding speech, playing chess, or even driving a car. Machine learning, on the other hand, is a subset of AI. It's where machines learn from data to improve their performance without being explicitly programmed. Deep learning is a more advanced part of machine learning. It uses structures called neural networks, which we will see later on, which are inspired by the human brain, to handle even more complex problems. For example, it's deep learning what enables AI to recognize faces and drive cars. Finally, generative AI is a part of deep learning that enables AI to create new and original content based on patterns that it learned already from existing data. Certainly, you could take the example of ChatGPT, which can write for you essays, or you can even have a conversation with ChatGPT. Now that we have seen the relationship between AI, machine learning, deep learning, and generative AI, let's shift our focus to see how these systems actually learn. Machine learning relies on three main techniques: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, machine learning models learn from labeled data and tries to classify these data points or predict specific outputs. It is similar to the way we learn at school. Giving students, for instance, or machines many pictures of how a boat looks like, they will learn how boats look like very well. Next, we have unsupervised learning. Here, data is unlabeled, and the machine learning model tries to group similar data points together. You could think of it as a chemist trying to identify combinations of chemicals that may lead to unique or unexpected reactions. And finally, there is reinforcement learning. This is how machine learning models learn through trial and error, where there is an agent that interacts with the environment and does actions in the environment, and the environment returns back either penalties or rewards. It's like training a dog. And this is how we can train machine learning models. Having spoken about how machine learning models learn, one of the mostly used models in AI is artificial neural networks. It's a cornerstone in deep learning to conduct complex tasks. Artificial neural networks are inspired by the human brain, and they learn as humans learn, and they can solve complex problems such as understanding language. But how do humans learn? Humans learn through their multitude of experiences. By attending school, for instance, and acquiring new knowledge, by meeting new people and gaining fresh perspectives, by embarking on new adventures, or by developing their skills through self-improvement. At the core of all of this learning, there is one essential element, which is the brain. Our brain functions as a dense network of fiber pathways consisting of 100 billion neurons, and it is through the network of those neurons we learn as humans. To get a clearer understanding of this, let's break the brain down to its fundamental structures that make up the brain, which is the neuron. A neuron is made up of dendrites, and those dendrites are the branches that are used to carry signals coming in. And based on these signals, the nucleus will either activate or not. And if activated, it will fire an electrical signal which will be propagated down to the axon. The axon is a single long connection which carries the signal and then will output it for the other neurons in the brain. Now, an artificial neuron mimics a real neuron. An artificial neuron will receive input as features, and then the neuron, if activated, it will result in an output. So, an artificial neuron works similarly as a real neuron. Now, neural networks are a group of neurons that mimic how our brains learn. So here we are not speaking of a single neuron, but a group of neurons. And supposedly we want to train this neural network to classify images if the image is a cat or not. The first thing we need to do is that we need to feed in a lot of images of cats and non-cats. And subsequently, this neural network with time will be capable of learning how cats look like. And in the future, if this neural network will receive an image of a cat that it has never seen before, it will be capable of easily classifying it as a cat. Just as humans learn how cats look like, if we as humans see on the street a cat or an image of a cat, our brain will directly indicate that this is a cat. In this presentation, we have explored the essence of artificial intelligence. We have seen its definition and what makes it unique from conventional programming. We have seen its history from just being a question to now being interrelated with many things we do in our daily lives. We have seen its branches and learning types. And finally, we have seen a brief functioning of neural networks. At the end, you could think of machines just like newborns. At the start, they know nothing. But with time, through data and training, they learn, adapt, and become fully functional, just as humans are.